Whenever we create a variable in C++, the program allocates a block of memory for it. Each variable gets its own memory location and space. Reference in C++ allows us to refer to already allocated block of memory using its address in the memory. Any change by the variable or the reference is directly reflected in the allocated block of memory. Both the variable and its reference always have the same value, since they point to the same location. Let's confirm this with an example. We create a variable a with value 10. If we create another variable named ref and assign a to it, the program creates a new variable ref, allocates memory block and copies the value 10 to the new memory block. C++ uses the operator ampersand to differentiate a variable from reference. Now, the program does not allocate memory for ref and it just points to the memory location of a. Let's change the value using both variable a and the ref to confirm our understanding. The output confirms that both a and ref are accessing the value from the same memory block. We must always initialize the reference to point to some variable. Compiler throws an error if we fail to initialize the reference. Also, you cannot assign a literal value to reference, since the literals don't have a location in memory, so compiler forbids it. Okay, so we understand the references, but why do we need them? In the current program context, it makes no sense to access the memory block using a reference when we can access it using a variable a. References are useful if you want to access the variable value in a different scope. Let's understand with an example. We write a function to calculate the average of scores in a vector. Here, the vector passed to the function triggers the creation of new vector variable for function and copies each element to the new location. We can create a reference parameter for the function which points to the memory block in vector and avoids the unnecessary allocation and copy. However, we should be very careful, since now if we make any change to the vector, it changes the original scores vector. So, we should pass it as const reference to avoid accidental updates. Although, in some cases, you might want to update the original variables. For example, if we write a function to swap the values of two variables, we would wish to reflect the change. If we test the program right now, we see the values are still the same, since the location of parameters in the swap function is different from the passed values. Let's change the arguments to reference and test again. We can see the changed values now. We should not overuse passing parameters as non-const reference and always prefer returning values from the function instead. If we only read the code from the function call, we cannot tell if it modifies the passed values. However, we can safely say the function changes the value of variable, catching return value. If we cannot find a way to return values from the function and are using non-const reference, it's a good idea to comment over usage to reflect the function modifies the values. For more programming videos, hit the subscribe button, leave a comment if you want me to cover any specific topic, and share with your friends. Thanks for watching.